When a megaship reaches the dock, the ocean journey is over, but the real race is just beginning. Thousands of steel boxes must leave the vessel, cross the terminal, enter the right stack, meet the right truck or train, and do it all without turning the port into a traffic jam the size of a city. This is not just a harbor, it is an automated logistics machine built to keep global trade from collapsing into chaos. The first interaction between the ship and the shore often belongs to human operators high in the sky. For a quay crane operator, lifting a massive box from a megaship is an intense, daily challenge of hand-eye coordination. Looking straight down from 50 meters up, they must guide 4 small pins into 4 exact pockets on a swaying container. It takes extreme precision and focus to safely pull the first box off a vessel that is holding 10,000 more just like it. But before that operator even touches the joystick, the port faces a massive data problem. From a distance, every container looks exactly the same. But to the terminal's vessel planners, no 2 boxes are the same. They must decide exactly which box moves first. Some of these boxes carry standard dry goods that can easily wait, but others require immediate, critical attention. Refrigerated containers, known as reefers, act as mobile cold storage units for fresh food, medicine, and temperature-sensitive chemicals. They cannot simply be placed in just any normal stack in the container yard. These reefers carry highly expensive, highly perishable cargo. They must be quickly routed to specialized electrified racks where their internal temperatures are instantly and constantly monitored. Modern automated terminals use remote tracking systems to process this critical data in real time. If the cold chain is broken during the handoff, the cargo is completely ruined. The port must execute this movement perfectly. To handle this massive variety of cargo, traditional container yards have heavily relied on rubber tire gantry cranes, or RTGs. Because they operate on heavy rubber tires instead of fixed steel rails, they provide incredible flexibility, moving between many different rows of stacked containers to find the exact box needed. Operators rely on sophisticated GPS and weight monitoring systems to ensure they never exceed the safe working load. Yet, as the sheer volume of global cargo increases, moving these massive machines around a busy yard physically takes a lot of time. Every single precious minute spent searching for a specific container or repositioning the giant crane is a minute the truck waiting below must sit idle. The physical movement of these heavy gantry cranes eventually becomes a structural bottleneck. The port cannot afford to have a multi-million-dollar machine waiting for a truck, or a truck waiting for a crane. They need a brilliantly designed, fully automated system that eliminates the wasted waiting time entirely. To solve this critical bottleneck, the newest mega terminals, like Evergreen's Terminal 7 in Kaohsiung, completely digitize the arrival process. As the crane unloads the ship, data is instantly transmitted to a central control room. There is no guessing and absolutely no manual paperwork. As trucks enter the delivery zones, advanced optical character recognition, or OCR, cameras instantly read their license plates, chassis, and specific container numbers. This invisible smart recognition system automatically guides the ground trucks into dedicated delivery lanes, effectively separating traffic to ensure a perfectly smooth flow. The central brain of the port knows exactly where the incoming truck is and where the yard crane is currently positioned. Drivers check in using automated digital kiosks, which seamlessly verifies their routing without them ever needing to exit the vehicle. This mathematical precision means the heavy container does not wait for the truck, and the truck does not wait for the container. Everything is continuously synchronized. By treating the port like a massive data network instead of just a physical parking lot, they entirely eliminate the idle time and human error that used to cause massive delays. Advanced security systems with fully comprehensive panoramic surveillance ensure every single movement is meticulously tracked in real time. Furthermore, this synchronized efficiency extends directly to the environment. The perfectly routed electric machinery dramatically reduces idling emissions, making the terminal not just drastically faster, but incredibly green. They utilize expansive eco-friendly warehousing services, boasting over 33,000 square meters of storage space. Solar panels proactively augment the electricity supply, and all wastewater is rigorously recycled. Smart SCADA systems are deployed to carefully monitor the energy consumption of every piece of machinery across the site. This invisible digital layer is the only way to manage a physical surge of 10,000 containers without the entire system breaking down into chaos. The invisible plan is set, but moving a 30-ton steel box from a ship to the shore requires immense mechanical force. Once the invisible plan is set, the data must become physical movement, and that movement starts at the first major bottleneck, the edge of the water. The ship-to-shore crane is where the invisible data from the planning room becomes a massive physical reality. In a modern semi-automated environment, these giant machines pull containers from the ship using heavy steel spreaders. But the true measure of a mega crane is not simply how much brute weight it can lift into the sky. It is how accurately it places that weight back down. When a 30-ton box is suspended 50 meters in the air, wind and inertia turn it into a massive pendulum. Traditional manual alignment takes precious time. Today, advanced camera systems and sophisticated sensors allow the crane to automatically align with ground vehicles waiting below. The software instantly counteracts the sway, drastically reducing the margin of human error and speeding up the cycle time for every single box. By automating the routine descent, the system can continually shave critical seconds off each lift to prevent costly terminal delays. Engineers eventually realized that to unload a megaship faster, making the hoist motors spin quicker, was no longer enough. There is a physical limit to how fast a steel cable can safely move a 30-ton box before the swing becomes uncontrollable. To beat this limit, they had to change the math. They had to lift more cargo at the exact same time. This is where advanced head block connections completely change the dynamics of the port. Instead of lifting one box per cycle, the modern crane can automatically switch its configuration to perform a tandem lift, grabbing two heavy 40-foot containers simultaneously. This effectively doubles the crane's output capacity without increasing its travel speed. But lifting two massive boxes creates a new, incredibly complex geometry problem. The containers sitting on the deck of a cargo ship are packed tightly together to maximize ocean transport efficiency. However, the gap between those two containers on the vessel is rarely the exact same gap required to safely place them onto the two individual truck chassis waiting down on the shore. If the crane cannot adjust this spacing, the entire tandem lift concept fails. The crane would have to drop the boxes in a holding area, forcing ground crews to separate them manually, which entirely defeats the purpose of lifting them quickly. To solve this mechanical bottleneck, engineers designed a highly sophisticated mechanism hidden inside the spreader itself. While the two heavy boxes are suspended high in the air, automated electric motors and hydraulic actuators inside the headblock dynamically adjust the physical distance between them. The operator can smoothly widen or narrow the gap from 0 to over 1,600 millimeters. But it is not just about the distance. The real world is rarely perfectly straight. The trucks waiting below might be parked slightly off-center, or the chassis might be angled. The advanced headblock can micro-adjust the skew, the angle, and the longitudinal offset of the two boxes independently while they are still flying through the air. This rapid micro-adjustment happens in a matter of seconds while the load is in transit. What this means for the terminal is absolute precision. The twin containers land perfectly aligned onto the ground vehicles, without ever requiring human workers to manually push, guide, or force the heavy steel into place. Because the system can seamlessly switch between single lifts and tandem lifts in under 2 minutes, the crane operator is always using the most efficient tool for the specific puzzle presented by the ship's stowage plan. This brilliantly engineered flexibility allows the megaport to maintain a relentless high-speed rhythm, proving that true heavy industry innovation is often about controlling complex geometry just as much as it is about applying raw lifting force to overcome the endless pressure of global trade. Every second saved here ripples through the entire logistics chain. It is simply brilliant engineering. Yet, even with highly advanced twin lifts, traditional cranes have a fatal flaw. If the truck below is delayed by traffic, the giant crane must stop its rhythm and wait, holding the heavy steel box in midair. The port cannot afford to have a multi-million-dollar machine waiting for a truck. To completely solve this bottleneck, engineers fundamentally changed the entire machine design. They split the crane into two entirely independent machines, creating a dual-trolley system. The primary trolley now has only one job: Pull the container out of the ship and place it onto a secure lashing platform located halfway up the crane's steel structure. Once the box is down, the primary trolley goes back to the ship immediately. A second, completely independent trolley then takes the container from that platform and lowers it safely to the ground vehicles waiting below. Because these two movements are entirely decoupled, the ship unloading process never has to stop for ground traffic. This parallel operation eliminates costly waiting times and dramatically speeds up the overall vessel turnaround time for the modern megaterminal. To successfully manage this incredibly complex mechanical choreography, crane operators no longer sit in glass cabins suspended high above the water, staring straight down for hours. Instead, they sit safely in ergonomic, remote control rooms miles away. They view the drop zone through panoramic high-definition camera feeds. The intelligent automation handles the long, repetitive travel distances across the crane structure. The highly skilled human operator only takes over the manual joystick for the final, precise placement, preventing operator fatigue and drastically improving overall operational terminal safety. But once the giant crane finally releases the box, the container enters the most crowded and dynamic part of the entire machine. The container enters the most crowded and dynamic part of the entire machine, the conveyor belt without a belt. The space between the ship and the storage yard is a constant flow of heavy machinery. If a vehicle arrives too early, it blocks the lane. If it arrives late, the massive crane waits. To clean up this critical horizontal transport zone, megaports are replacing traditional diesel fleets with advanced electric terminal tractors. Equipped with offset cabs for maximum visibility and powerful dual-gun fast charging systems, these electric trucks take the first crucial step in eliminating terminal exhaust emissions while maintaining the relentless high-speed pace of global trade. But to truly eliminate human hesitation from the handoff, the transport vehicles must drive themselves. At advanced mega-terminals like Mawan Port, autonomous electric trucks receive precise routing instructions directly from the central software. Instead of relying blindly on magnetic strips buried in the concrete, these intelligent machines use powerful AI vision, dynamic 3D scanning, and advanced LiDAR sensors to constantly read the complex physical world around them. If an unexpected obstacle appears in their designated lane, the truck's central brain reacts instantly to halt the heavy load, ensuring absolute operational safety without any manual intervention. When the autonomous truck finally arrives beneath the giant ship-to-shore crane, the true engineering value of the system becomes obvious. The physical alignment must be absolutely flawless. Even a tiny margin of error will cause the crane's heavy steel spreader to miss the drop, forcing a manual correction and wasting precious seconds. Automation entirely removes this dangerous guesswork. Mathematical precision ensures the physical handoff between the horizontal truck and the vertical crane is perfectly synchronized every single time. This master system flawlessly coordinates dozens of autonomous trucks, ensuring they weave through the terminal's highly complex road network without ever crashing or causing gridlock. By completely digitizing the transport cycle, the megaport ensures continuous cargo flow. The autonomous fleet navigates the chaotic environment with the cold, calculated precision of a computer network, proving that perfect timing is the ultimate weapon against industrial chaos. Some mega terminals take this automation a step further by removing the driver's cabin entirely. They use flat, automated guided vehicles or AGVs, operating completely without human presence. These low-profile machines are constantly guided by highly complex routing algorithms and transponders embedded deep in the pavement. Together, they act as a massive, invisible conveyor belt stretching across the terminal. The newest generations rely entirely on highly efficient lithium-ion battery drives. This advanced power source drastically reduces the overall weight of the vehicle and completely eliminates harmful exhaust emissions. With extremely low energy consumption and significantly reduced mechanical complexity, these autonomous electric platforms provide a highly sustainable, quiet, and relentless method of moving thousands of heavy steel boxes from the water into the storage yard. Because these flat AGVs frequently carry payloads of up to 70 tons, their daily energy drain is absolutely immense. A working port cannot afford to park a multi-million-dollar vehicle for several hours just to recharge its battery. To keep the machines moving, the engineering solution is entirely mechanical. When the central software detects that an AGV is running critically low on power, the vehicle is automatically routed into a specialized, robotic battery exchange station. It parks with exact millimeter precision. In less than 5 minutes, an automated mechanical arm extends outwards, grips the depleted multi-ton lithium-ion battery pack, and smoothly pulls it out of the chassis. Immediately after, it slides a fresh, fully charged battery directly into the machine. By minimizing energy use during standstill and utilizing this rapid exchange system, the vehicle returns to the terminal cycle almost immediately. This automated pit stop allows the port to maintain a relentless, 24-hour operational rhythm without ever suffering from the crippling downtime normally associated with charging massive industrial electric vehicles. Not all megaports rely on flat transport vehicles. Terminals like Trolleys utilize automated straddle carriers. Instead of waiting for a crane to place a box onto its back, this tall, mechanical frame drives directly over a grounded container, automatically aligns its spreader, picks the massive weight up, and transports it. Because they do not have a cabin, these towering machines operate flawlessly under the constant supervision of a central smart system. However, regardless of the physical machine type used, the ultimate engineering challenge in the horizontal transport zone is always traffic routing. One blocked path can instantly slow down automated machines that never even physically touch each other. The core software must constantly calculate hundreds of intersecting paths every single second. It predicts exact arrival times, manages strict right-of-way rules, and dynamically adjusts speeds to ensure these heavy robots pass each other safely in a crowded space. To keep this specific fleet moving, modern electric straddle carriers utilize high-capacity fast charging systems. Instead of physical battery swaps, the central smart software automatically assigns short charging tasks whenever the machines experience a brief idle moment. This strategic, Hands-free megawatt charging ensures the heavy lifting equipment can seamlessly operate for up to 10 continuous hours. Whether the cargo is carried by an AGV or an automated straddle carrier, the final handover point to an outside truck is absolutely critical. At highly automated truck transfer zones, the system creates a secure barrier between outside drivers and giant machines. As an external highway truck enters the transfer portal, advanced line scan cameras and lasers instantly capture its chassis number, check the door direction, and rigorously verify the physical presence of the security seal. By fully digitizing this specific transfer point, the entire handover process happens flawlessly, ensuring that fragile human workers never have to step foot inside the deadly, highly active danger zone of automated heavy machinery. Transport gives the container motion, but the yard gives it memory. At night, a modern mega terminal looks like a perfectly synchronized city. When the horizontal transport drops a container into the yard, the real logic begins. A container yard is not just a massive physical parking lot. It is a highly complex, three-dimensional database made of heavy steel. The port has to know exactly where every single box fits, and exactly when it needs to leave. If a truck arrives tomorrow to pick up a specific container, and that container is buried underneath 4 other heavy boxes, the crane has to move all 4 out of the way first. A wrong decision here will not fail immediately. It will fail 6 hours later when terminal traffic peaks. Therefore, the best yard plan is never the one holding the most cargo. It is the plan creating the absolute fewest future moves. Building the towering machines that execute this logic requires immense industrial engineering. From the precision design of their hybrid battery assemblies to the final rigorous quality testing on the heavy production line, modern straddle carriers are built to operate endlessly under punishing conditions. They act as the tireless, mobile workers of the terminal yard. Their towering frame allows them to drive directly over rows of grounded containers, pick up a 30-ton load, and carry it from the automated ship cranes deep into the dense storage blocks. Because they operate continuously, day and night, their mechanical reliability is absolutely paramount. They are designed with specialized hybrid or electric drivetrains that drastically reduce fuel consumption while providing the massive low-end torque required to smoothly lift heavy steel boxes into the air, perfectly ensuring the terminal's relentless rhythm never skips a single beat during peak hours. To achieve extreme storage density, megaports utilize massive automated stacking cranes, or ASCs. These heavy rail-mounted machines build incredibly dense, multi-story blocks of steel containers. By fully decoupling the waterside unloading moves from the landside delivery moves, these automated stacking cranes can operate constantly in the quiet background. They utilize sophisticated algorithms to continually prepare the yard for the next massive wave of incoming trucks. If the system predicts a specific box will be needed for a morning rail departure, The crane automatically digs it out during the midnight hours and places it at the very top of the stack. This invisible background processing is the core secret to maintaining high-speed throughput. It ensures that when a truck finally arrives at the automated transfer zone, its assigned cargo is immediately ready to go without delay. To maintain perfect memory of this massive steel database, every single container move must be flawlessly tracked. Ports utilize advanced real-time location systems combined with precise differential GPS. The exact three-dimensional coordinates of a box are permanently locked into the digital software the exact moment a crane drops it. When an outside highway truck driver enters the highly restricted yard area to retrieve a box, they do not hand over paper documents to a ground worker. Instead, they interact with specialized digital kiosks. These rugged terminals allow safe, contactless communication between the human driver and the massive automated yard cranes operating nearby. This entirely digitized handover ensures the correct heavy container is flawlessly transferred to the right truck chassis, maintaining absolute data integrity while keeping fragile human workers safely away from the dangerous, highly active lifting zones. Supervising this incredibly dense yard are highly skilled remote operators sitting safely in quiet control rooms miles away. Instead of physically driving one machine, they carefully oversee dozens of automated yard cranes simultaneously through multiple high-definition camera feeds. The intelligent automated system handles the vast majority of the routine lifting. The human operators constantly step in to aggressively reshuffle containers, proactively adjusting the deep stacks to ensure that a heavy box needed today is not buried beneath 3 boxes needed tomorrow. Rehandling is the absolute enemy of port efficiency. By having human intelligence oversee the complex geometry of the yard, the terminal ensures the continuous, flawless, rapid movement of thousands of massive steel boxes. But traditional container stacking has finally hit a physical limit. Modern megaships now carry over 24,000 containers. In standard ports, these massive boxes are repeatedly stacked up to 6 tiers high. The more you stack on top of each other, the more you eventually have to dig. To solve this inherent structural bottleneck, engineers fundamentally redesigned the entire concept of the container yard. They created the incredibly advanced high bay storage system. Instead of stacking heavy containers directly on top of one another, the boxes are carefully slotted into a massive, heavily reinforced 11-story steel rack. It operates exactly like a giant automated warehouse, but built to handle 30-ton ocean containers. Inside this towering steel matrix, highly automated stacker cranes travel rapidly up and down the long aisles. Because every single container sits securely within its own private compartment, the system provides 100% direct access. Any individual box can be retrieved instantly without ever needing to move another box out of the way. There is absolutely zero reshuffling and zero wasted energy. When a truck arrives, the automated crane simply lifts the required container out of its specific slot and places it onto a continuously circulating underground pallet system. This invisible lower mechanism carries the heavy load directly to the landside interface. Because these two internal movements happen simultaneously, the system achieves maximum operational speed with perfect precision. Furthermore, this vertical storage technology drastically shrinks the physical footprint required by the port. It allows mega terminals to handle massively increased global cargo volumes without needing to continually expand their expensive coastal land area. The stationary racks provide a highly efficient, constant transfer interface, completely decoupling the waterside straddle carriers from the highway trucks waiting on the other side. This critical separation ensures that a sudden traffic delay in one specific zone never forcefully stops the machines operating in the other. The system is also designed to be surprisingly sustainable. Selected external sides of the massive steel structure can be completely covered with advanced, highly effective soundproofing panels, drastically reducing the excessive noise pollution normally generated by heavy port operations. By treating massive steel shipping containers precisely like small parcels in an automated digital warehouse, this revolutionary vertical architecture definitively eliminates the crippling daily problem of deeply buried cargo. It flawlessly transforms the traditionally chaotic container yard into a highly organized machine, proving that sometimes the ultimate heavy industrial engineering solution is to entirely change the foundational physical geometry of the space itself. But a perfectly organized yard still means absolutely nothing if the cargo cannot escape the terminal. In fully automated environments like Qingdao Port, the entire terminal moves with a quiet, relentless rhythm. From the completely unmanned yard blocks to the electric horizontal transport, guided by artificial intelligence, the internal system is a flawless choreography of heavy steel. However, the true measure of a megaport's success is not just how efficiently it stores cargo inside its fences. It is how rapidly it can push that cargo out into the world. If the exit paths become blocked, the yard quickly fills to maximum capacity, and the massive ship-to-shore cranes are forcefully stopped. The entire billion-dollar logistics machine crashes. Before a container can finally leave the terminal's strict boundaries, it must be scanned one last time. Sophisticated image recognition systems instantly capture every physical detail, ensuring the port's software exactly tracks what is leaving. The greatest structural choke point in any logistics network is the truck gate. When hundreds of highway trucks arrive simultaneously, they can easily create massive traffic jams that spill back into the surrounding city. To solve this critical bottleneck, modern terminal gates are heavily automated. As a commercial truck drives through an advanced ochre portal at a steady speed, highly accurate line scan cameras instantly read its license plate, chassis number, and the container's physical security seal. The driver does not ever hand over paper documents to a ground worker. Instead, they pull up to specialized self-service registration kiosks to rapidly verify their booking information. This entirely digitized screening process drastically slashes the necessary turnaround times, maintaining a constant, high-speed flow of heavy vehicles entering and exiting the restricted facility without causing any crippling congestion. By brilliantly combining these fully automated gates, mandatory appointment systems, and massive, all-electric rail-mounted stacking cranes that proactively prepare specific boxes in advance, megaports can drastically reduce the average truck turn times. Today, getting a heavy truck into the complex facility, loaded with the correctly assigned 30-ton container, and safely back out onto the public highway in under 40 minutes is the ultimate benchmark of a highly efficient exit strategy. This meticulous operational velocity ensures that the sprawling physical container yard never transforms into a stagnant storage warehouse, constantly freeing up vital ground space to aggressively absorb the next massive wave of incoming ocean cargo. But highly optimized highway trucks alone simply cannot handle the immense physical volume of a modern megaship. To truly release the immense pressure from the crowded terminal, the cargo must be rapidly moved by heavy rail. The port's internal supply chain utilizes specialized towering straddle carriers and extremely powerful reach stackers. These versatile machines efficiently transfer thousands of heavy steel boxes directly out of the dense storage blocks and rapidly deliver them into the dedicated intermodal rail terminals. This critical rail connection acts as the ultimate pressure release valve for the entire logistics system, ensuring the port's internal operations can continuously breathe while aggressively preventing the endless flow of global trade from gridlocking the local road networks. Expanding this critical on-dock rail capacity is the ultimate long-term strategy for any advanced modern megaport. Maximizing the extensive use of heavy rail brings incredible logistical and environmental benefits to the surrounding regional infrastructure. Just one fully loaded double-stack train can completely eliminate up to 750 heavy commercial truck trips from the highly crowded local highways. This massive physical consolidation drastically reduces dangerous diesel pollution while exponentially increasing overall cargo handling efficiency. To achieve this, megaports must constantly construct sprawling new rail yard facilities, creating centralized staging areas perfectly capable of quickly assembling and rapidly dispatching massive supply trains that measure nearly 2 full miles in total length. Because highly efficient freight rail connections are the absolute only way to sustainably support continuous container growth, major ports are aggressively investing hundreds of millions of dollars to actively double their internal rail capacity. These massive staged investment programs fundamentally focus on building advanced new rail terminals deep inside the highly restricted port boundaries. By heavily funding the complex construction of extended rail tracks and acquiring advanced loading machinery, port authorities actively protect the vital supply chain costs. It is a simple but incredibly powerful logistical equation. Every single million massive steel containers successfully moved on the internal rail network effectively removes nearly 1,000 heavy truck movements from the public roads every single day. This heavy industrial investment is absolutely critical to keeping global exports highly competitive, while simultaneously protecting the daily lives and local economies of the surrounding urban communities. Inland intermodal rail terminals operate precisely as massive industrial machines in their own right, serving as the critical final destination for the long trains departing the coastal megaports. Strategically located at the major logistical crossroads deep inside the continent, these sprawling combined terminals are engineered to handle thousands of incoming containers every single day. The physical scale of these impressive facilities is absolutely staggering. They feature multiple parallel railway tracks, each stretching over 700 meters long, specifically designed to efficiently process up to 16 massive cargo trains daily. The powerful heart of the operation lies in the towering rail-mounted gantry cranes. Standing over 20 meters tall, these electric giants smoothly travel up and down the incredibly long tracks. They expertly pull the heavy, 30-ton ocean containers directly off the specialized train cars and precisely lower them onto waiting highway trucks for the final short-distance delivery to the local warehouses. However, the seamless transfer of heavy cargo from rail to road requires incredibly rigorous safety protocols. Before any truck is allowed to safely enter the highly active lifting zone, it must pass through heavily automated gate systems. Advanced photo gates meticulously record the physical condition of the transport equipment, ensuring absolute data traceability. Furthermore, incredibly strict centralized gauge controls carefully check the exact weight, physical dimensions, and structural safety of the incredibly heavy loads before they are ever hoisted high into the air. Every single mechanical movement is actively monitored from a sophisticated centralized command post. The highly trained operators inside meticulously oversee the complex choreography of the towering gantry cranes and the massive reach stackers maneuvering below. These heavily reinforced reach stackers are specifically utilized to perfectly handle the heaviest, most awkwardly shaped loads, easily lifting 45-ton containers and specialized semi-trailers with absolute mechanical precision. By completely shifting the massive volume of long-distance cargo transportation away from crowded public highways and onto these highly organized rail networks, these advanced intermodal terminals actively achieve an incredibly high level of environmental efficiency. They successfully reduce total carbon dioxide exhaust emissions by up to 85% compared to traditional, long-haul road transport. They stand proudly as the ultimate logistical link, flawlessly proving that the true power of a modern global supply chain relies entirely on perfectly synchronizing the massive coastal ships with the deep inland rail networks, ensuring that heavy international cargo always keeps moving continuously forward. As rail volumes heavily increase, brilliant engineers are constantly inventing much faster, more intelligent ways to seamlessly load these massive transport trains. Innovative intermodal solutions, like the highly advanced Lohr railway system, feature specialized train cars that fundamentally change the loading physics. Instead of forcefully requiring massive overhead cranes to slowly lift the cargo vertically, these unique rail cars are mechanically engineered to safely pivot diagonally outwards. This brilliant structural design allows standard, unmodified highway semi-trailers to be driven directly onto the heavy train platform horizontally. In a matter of mere minutes, an entire massive train can be fully loaded and immediately dispatched. This highly efficient pivot technology entirely eliminates the strict need for expensive heavy lifting infrastructure, dramatically speeding up the crucial intermodal transfer process. From the tracking software to the automated trains, the port seems to run entirely by itself. But the reality of heavy industry is never perfectly clean. A modern megaport is not automated because nothing ever goes wrong. It is automated because something always can. The routine inherently belongs to the machines, but the critical exceptions will always belong to the highly skilled human workers. By utilizing advanced digital twin technology, the central operating software creates a live, high-definition, three-dimensional simulation of every single active container and massive yard crane. The intelligent system uses sophisticated LiDAR arrays and complex artificial intelligence vision to constantly predict dynamic wind speeds, rigorously monitor equipment health, and flawlessly prevent dangerous physical collisions across the sprawling facility. Because the background AI is so remarkably reliable, a single highly trained human operator can safely sit in a quiet command center and effortlessly supervise up to 6 heavy industrial stacking cranes simultaneously. But the real physical world is inherently messy and constantly chaotic. A critical security seal might be mysteriously broken. A heavy steel twist lock might become dangerously jammed inside a corner casting, or a vital refrigerated container might unexpectedly lose power. When an unpredictable exception suddenly occurs, the smart system instantly flags it on the centralized alarm board. The human supervisor immediately steps in, actively diagnosing the complex operational issue through live high-resolution camera feeds and making a rapid, crucial judgment call. The ultimate engineering goal of this advanced control room is never to completely eliminate mechanical problems, because that is physically impossible in heavy industry. The true goal is to aggressively catch the specific problem before it actively cascades. When one single massive container fails, rapid human intelligence carefully ensures that this minor isolated incident does not instantly become a crippling logistical delay for tens of thousands of other heavy boxes moving relentlessly forward through the automated terminal. The physical world out on the sprawling docks is completely full of unpredictable natural variables. Strong ocean wind easily causes massive, 30-ton steel containers to violently sway back and forth like massive, uncontrollable pendulums suspended high in the air. Even with the absolute best electronic sway control systems actively counteracting the immense momentum, the incredibly delicate final drop onto a narrow waiting truck chassis requires intense spatial awareness. The highly intelligent automated software system can flawlessly get the heavy steel box exactly 99% of the way there. However, overcoming the final few inches of extreme physical resistance and achieving perfect millimeter alignment is exactly where experienced human oversight truly shines. The human operator utilizes their intuitive understanding of complex geometry and real-world physical momentum to smoothly guide the heavy steel load perfectly into the incredibly tight corner pockets, proving that sheer mechanical force is practically useless without the highly nuanced, split-second corrections provided by a highly trained and completely focused human brain. Moving completely out of the high-tech control rooms and directly down onto the concrete, massive megaports still absolutely rely on extensive networks of highly skilled stevedores and dedicated dock workers. They must physically handle the extremely awkwardly shaped oversized cargo, safely secure the highly complex industrial materials, and actively execute the incredibly complicated physical deck planning that artificial intelligence machines simply cannot properly process or safely manipulate. This physically demanding, hands-on labor fundamentally ensures that the most difficult, non-standard maritime freight is always flawlessly integrated into the relentlessly fast-paced global supply chain. Because ultimately, international global trade does not magically run purely on digital software code. Before a massive ocean ship can safely sail back out into the violent, unpredictable ocean storms, every single massive steel container must be absolutely physically locked down to the vessel's deck. Brave men and women must carefully navigate the extremely deep, narrow steel canyons of the fully loaded cargo ship. They manually lift extremely heavy steel turnbuckles and forcefully insert long, rigid lashing bars with pure physical muscle. The entire multi-billion-dollar automated port system, the electric autonomous ground vehicles, the highly advanced artificial intelligence control rooms, the towering three-dimensional stacking yards, and the high-speed rail networks, only functions efficiently because calloused human hands securely lock the immense cargo first. The absolute pinnacle of modern industrial automation still fundamentally relies on the exact same brutal, heavy physical labor that started the maritime shipping industry over a century ago, flawlessly securing the endless daily flow of our modern global commerce.